Welcome back to Aurora Tech Channel. Today, I'm going to review the Bambu Lab P1P printer. Since Bambu Lab launched its first X1 printer about 6 months ago, it has really changed the 3D printing industry quite a bit. Major manufacturers are starting to make fast printing printers, and I've definitely reviewed several in my more recent videos. So I would say Bambu Lab is a bit of a wake-up call to all manufacturers. As their flagship Bambu Lab X1 Carbon with a multi-material system cost $1,500, it may not be very affordable for many hobbyists. So they just launched a simplified version, the Bambu Lab P1P. It comes at a much more affordable price of $699, but as expected, when the price goes down, some features have been removed. Let's take a look at the hardware of this printer. It shares many of the same components as the X1. They are both Core XY kinematic 3D printers with linear rods on the Y and Z axis and a carbon rod on the X axis. They have the same extruder and hot end, which can reach up to 300 degrees Celsius. They have the same triple Z axis lead screws and the same sturdy box frame. And this printer supports Wi-Fi printing, or rather cloud printing, as you still use the same Bambu Studio slicer that allows you to send print jobs onto cloud and print directly. If you mainly print PLA, PETG, TPU, and other low-temperature filament, it basically works just like the X1, however, some features have been removed. This printer doesn't have an enclosure, the micro lighter for pressure advanced calibration has also been removed, and it has no color touchscreen and instead has an LCD screen. The cool plate and engineering plate have been changed to a double-sided textured PEI sheet. The built-in camera, LED light, and auxiliary cooling fan are now all optional upgrades. In this video, I will print with different materials to see how this P1P works and talk about the pros and cons and what I think of this printer. I would like to thank Bambu Lab for sending this machine to me for review, and with that, let's get started. As this machine comes fully assembled and in one piece, all you have to do is remove some protective materials and mount the filament holder and the filament guide. So let's just jump right into testing and print some different materials to see how this printer works. I will start with the 3D benchy included in the SD card. I remember when I tested the X1 Carbon, the 3D benchy inside the SD card was printed in around 17 minutes. That benchy didn't have a regular 0.2mm layer height and had a 0.25mm layer height with a lower infill with the print speed set to 400mm per second and the acceleration set to 20k, instead of the default profile of a 200 to 300mm per second speed and a 10k acceleration. But 17 minutes is still a very good time, so let's see if this P1P can print at the same speed. It seems the textured PEI sheet doesn't stick perfectly. I'm not sure if this is because it's brand new and I haven't cleaned it with isopropyl alcohol yet, but I'll just let it finish and see what happens. The benchy finished in 20 minutes and 14 seconds. It looks fine and the quality is still pretty good. It has zero stringing and the cooling and overhanging all look good. The line here is caused by the filament shrinking as the density of the model is higher at the bottom. This model was printed 3 minutes slower than the X1, so let's go to the slicer and see what the difference is. I would just use the default PLA profile for this P1P, where the printing speed is somewhere between 200 to 300mm per second with a 10k acceleration. As you can see, the printing time is 41 minutes and 17 seconds. But when I switch to the X1 Carbon profile, the printing time is just 33 minutes and 15 seconds, which is 24% faster. As the motion system, extruder, and hot end are all the same, I don't understand why the P1P is slower. So I asked Bambu Lab, and they told me the layer time of the P1P is set to 8 seconds, while the layer time of the X1 carbon with the auxiliary fan is set to 4 seconds. If the auxiliary fan is added to the P1P, it can be set to have a 4-second layer time, and both printers will print at the same speed. I tried to just change this setting and reslice the model, and yes, the printing time is now 33 minutes, which is the same as the X1 carbon. Next, I will use the default profile and slice a calibration cube. It still didn't stick perfectly, so I may need to clean this bed with 99% IPA after this print. The cube looks alright, and the surfaces are clean, even though it's a bit hard to see with the Bambu Lab white PLA filament. The dimensions are also accurate and within an acceptable range. After the bed is cleaned, I will try a tougher print. I made this honeycomb box with tiny patterns that aren't very easy to print, so let's see how this P1P does. The result is awesome with almost zero stringing, and the bed also stuck pretty well after cleaning. I'm very happy with the result, especially considering how tiny this box and its patterns are. Then, I will print another tough print, the Eiffel Tower. This model took over a minute to slice using the bamboo slicer, and the printing time is 7 hours and 44 minutes, which isn't bad. When I tried to slice the same model using Cura, it only took around 10 seconds, but the printing time of a normal printer like the Ender 3S1 would take over 16 hours. This print has a little bit of stringing, but overall it's really nice. The tower has no missing parts from bottom to top, and the tiny tip at the top is also printed perfectly. As printing this tower didn't have much distance for the print head to accelerate, it was about 2 times faster than a normal printer. After that, I will try another tough model of Voronoi deer. This tiny deer turned out pretty nice. There are no missing parts on the body, and the stringing at the horn is also better than I expected. Next, I will try printing some functional parts. I will use Voxel PLA Pro to print this IKEA end table filament holder. The bed seems to stick pretty well after cleaning. All parts were printed well, and though the threads on the bolt are not perfect, all parts are functional. I will also print another longer 90-degree arm to hang the filament at another angle. This long part is also printed just fine, and the bottom sticks nicely. Then, I will print a card holder. This model has a pretty small contact surface, so I added a brim. The print turned out pretty good, and I have no complaints. The lever requires accurate clearance in order to move and allows you to push out the card like this. After that, I will try some PETG, so I'll use Airy One White PETG to print a phone holder. Generally, printing these honeycomb patterns with PETG may cause some stringing, but the extruder handles this very well and there's no stringing. Up next, I will print this model of Snorlax with Airy One TPU. The default TPU profile sets the maximum volumetric speed to 6.4 cubic millimeters per second, while PLA is set to 21 cubic millimeters per second, and ABS is set to 22 cubic millimeters per second. So the print speed will be reduced, even if the print speed and acceleration are set to the same numbers. Other than a tiny bit of stringing, the model looks alright and is in line with the ones I print on normal speed printers. Next, I will try printing with ABS. I will print this boomerang with a large footprint on this PI sheet without glue and see how it does. In the middle of the print, the bed can't stick to the part. As Bambu Lab also sent me glue, I will apply their glue on the PI sheet and try again. It's doing a little better, but the print still can't stick well enough. I also wanted to check to see if this glue works well with ABS, so I will print a smaller benchy using ABS. I just used this 12-minute ABS benchy G-code for the X1 carbon, and it seems that it'll work pretty well too on this P1P. However, the ABS benchy still didn't stick to the bed, so I will go back to using my Elmer's Craft Bond Extra Strength glue stick. This time, the ABS benchy could finish printing in 12 minutes, except for the fact that there are layer adhesion issues as this printer doesn't have an enclosure. And even if the glue does help it stick to the bed, the ambient temperature of my garage is just around 15 degrees Celsius, so the ABS will crack when it cools too fast. I will print a small solid part that won't crack like the benchy. This tripod mount for a GoPro has a high infill bottom, and it finished without any issues. It seems my glue works just fine with ABS if the part is not too tall or has thin walls. So I will reprint the boomerang and see how it looks. This time, the part was printed successfully and it sticks very well. A part of just a few millimeters in height normally won't crack, so this part is printed very nicely. After that, I will print a phone mount with nylon carbon fiber. The print is not very clean since the default profile set the nozzle temperature to 290 degrees Celsius. It should be able to avoid some dripping if I lower the temperature a bit. I will also print two smaller parts for this mount. They can fit together without any problems, and after some easy cleanup on the surface, this mount is functional and still looks pretty good. Finally, I will try printing with polycarbonate. I will print the fan support model from Bambu Lab, as I may install the auxiliary fan later. The print looks pretty nice from the front, but the back is warped and the thin wall cracked, just like it did with the ABS benchy. It seems ABS and PC are too tough to print without the enclosure, especially in winter, as the cold ambient temperature is really an issue. But I do still want to print a smaller part with a solid body, so I will print another GoPro-style phone mount. As I printed this with 75% infill, the print stuck well to the bed, and the solid body also won't shrink that much and won't cause warping and layer separation. I also printed other smaller parts for me to mount the phone on aluminum extrusions. All of the small parts are printed perfectly, fit together nicely, and I can now mount the phone on the tripod with an extension that allows me to shoot printing clips from a closer distance. Okay. Let's talk about the pros and cons of this printer, starting with the pros. 1. This printer prints super fast. The maximum print speed of 500 mm per second and the maximum acceleration of 20K are the same as the Bambu Lab X1 and are faster than almost any other printer available in the market. The normal printing speed of this printer is 200 to 300 mm per second with 10K acceleration, which is still faster than most printers' top speed and acceleration. 2. The print quality is great. I tried printing the toughest models I have, like the Eiffel Tower and my Honeycomb box, at the high speeds of 200 to 300 mm per second. And most printers I have can't get the same results as this printer, even when printing at a much slower speed of 50 to 60 mm per second. 3. The bed leveling and nozzle cleaning mechanisms work really well, wiping off the residue from the nozzle automatically. The bed leveling is also very consistent, and I get perfect results every time, even when printing a bunch of small objects that use up the entire print bed. 4. The Bambu Studio Slicer works great with the P1P. I use cloud printing on every single print, and it worked flawlessly. This is probably the best Wi-Fi 3D printing experience you can get from a stock printer. 5. The print volume is the same 256mm cube as the X1, and they both have a compact footprint. This printer occupies less space than any Cartesian printer, and the required space is even less than the Ender 3, which only has a 220 by 220 by 250 print volume. 6. The textured PEI sheets sticks well, and the quality is better than the textured PEI sheets that come with other printers, as well as the ones you can buy off Amazon for around $20 to $40. 7. This printer lets you print an enclosure to work better with materials like ABS and ASA. If you want a hardened steel nozzle to print abrasive filament, you can spend another $15 for that upgrade. The prices of their accessories are very reasonable, especially considering that I've spent $300 on a high-temperature core for my Ultimaker S3. 8. If you need multi-material printing, this printer also supports the AMS multi-material system, but it does have its own disadvantages compared to a dual print head or IDEX printer. You can watch my review video on the X1 Carbon if you're interested. Now for the cons. 1. The LCD screen has an unload feature where it will automatically heat up the nozzle and unload the filament, but it doesn't have a load feature, so you still need to manually heat up the nozzle and press the button a few times to load new filament. It also doesn't prevent you from loading filament when the nozzle is cold, so you can hear the stepper motor skipping when you load the filament without preheating the nozzle. 2. When I send a complex model from the slicer, the LCD screen has to wait for between 30 seconds to a minute to download and unzip the file. When you're printing a model that takes hours, it really isn't that much. But when I send the same model to the X1, the touchscreen works faster and without delay, possibly because it has its own processor. 3. This printer takes longer to start as it's going to do input shaper calibration every time before the print starts. So including heating time for the nozzle and print bed and auto bed leveling, it will take 8 to 9 minutes before it actually starts printing. When I use the X1 Carbon, I would normally disable all calibration and leveling. But for this P1P, it doesn't come with a micro lighter. You can't do pressure advanced calibration for different filament, but just using their preset parameters still seems to work okay. So, missing the micro lighter doesn't seem like that big of a deal to me. 4. As this printer doesn't come with an enclosure and glass top that allow you to fully enclose the printer, when printing large parts with ABS, ASA, or polycarbonate, and with glue applied, the print does stick well to the bed, but it may still have the issue of layer separation, as the ambient temperature can't be maintained at a stable level, especially in winter, where my garage's temperature is around 15 degrees Celsius. It would be very challenging to print these materials without a fully enclosed machine. The heated bed is also 10 degrees Celsius lower than the X1, which can only heat up to 100 degrees Celsius. In conclusion, this Bambu Lab P1P is going to have a huge impact on the existing 3D printer market again, just like their flagship model, the X1 Carbon. When compared to Bambu Lab's printers, other printers at the same or even much higher price points in the market look outdated. The only two machines that come close are the Eiffel Sun B400 and the Ender 5S1 with the Sonic pad. However, the P1P is still ahead in terms of print speed, print quality, and overall user experience. If manufacturers making $500 to $5,000 printers can't step up their game, I wouldn't be surprised to see Bambu Lab take over their market shares in the near future. If your budget allows it, I think the X1 is still the way to go. This doesn't mean the P1P is not good, but let's use a real-world example to help explain why I came to this conclusion. So when you order a burger meal, you can get a burger, fries, and a drink, and let's say that would cost you $10. But if you order just the burger and drink without the fries, that still costs you $9. As a manufacturer, when they cut features, they deduct the cost from the price. But when they add features, they will probably add to the retail price, which includes the cost and profit. So, when comparing the P1P with the X1, you pay $300 less, but you also give up the enclosure, the glass top, the micro lighter, the color touch screen, the camera, and other minor details and upgrades. A generic, reasonable quality aftermarket aluminum frame with an acrylic covered enclosure will still cost you $200 to $300. If your budget allows it, I think paying $300 more to get the $999 X1 is still the better option. On the other hand, if you just print PLA, PETG, and TPU most of the time, you can't go wrong with this $699 P1P, as it's still far ahead of its competition in the same price range. That's all I have to share about this printer, and I hope you found this helpful. That's it for this video. If you like this video, please hit the like and subscribe button, and make sure to click the notification bell to receive new video updates. I will see you next time.